All right, well, we may as well get cracking. Um, so, welcome to the introduction to PCB design in Altium. This will be the second time running this workshop. Last semester was the first time, and I haven't changed anything, so I think it ran reasonably smoothly last time. But yeah, we'll see how we go. Please let me know any feedback and improvements or anything else you'd like to see. I'm John. I'm with MUEC and division of MUEC called ARP, which is the Autonomous Robotics Research Project. So hopefully everyone has access to some sort of version of Altium. So you can download Altium if you're running Windows. UniMelba is part of their student license program, so you can access a six monthly recurring student license. Additionally, Altium is on the FEIT student desktop, so you can access that through My Uni Apps, but you'll still need to input your license details, I think, by signing in or something like that. I haven't actually used it on there, so if anyone has any troubles with that, let us know. But yeah, I'm running locally on my Mac in Parallels, a software called Parallels, which I can boot a Windows virtual machine in, and then I've got Altium installed on that. But basically, it's Windows only software, unfortunately. So get that registered. So if you can just indicate to me via the reactions or something, if you don't have access to Altium at all, or if you do, put a tick, or if you don't, put a cross or something like that, thumbs up, anything. Looking pretty good, I think. But I'm not seeing anyone indicate in the negative yet. So yeah, sing out if you're having any issues, but I'll sort of assume that everyone is good to go and has Altium. So what we'll be doing before we jump into the Altium stuff, we're going to be learning the basics and the language of PCBs themselves, because it's no good being able to design a PCB and talk about PCBs unless we know exactly what's going on with them. What are they? How do they work? You know, what are their features? What's the language associated with them? So the first half is, first half of the workshop or so is sort of dedicated to an overview of PCBs. And then we'll be getting into the Altium stuff once we can all talk the lingo. So as you know, PCBs are everywhere, and the modern electrical engineer should certainly know how to design them, basically. They're so cheap and so easy to access, you know, the design software and the manufacturing stuff as you know, professional and hobbyists these days. There's sort of there's no way around it. You just sort of need to use it. There's maybe like one uni course in particular that actually has PCB stuff and Altium as part of it. I think I haven't actually done it yet. It's like ESD or ECD or something like that as part of the masters. But yeah, I think the sooner you can do it, the better off you're going to be. So we're going to cover the basics of what a physical PCB is, the basics of the design process in Altium, and then we'll go through a little project design together, working through an actual little board. So your first PCB design. There's a bunch of stuff that we don't cover. A lot of advanced generic PCB topics, stuff like differential and match length pairs, high frequency circuit concepts, which is, you know, super important if you're designing circuits that, you know, do fast switching or radio frequency type stuff, you know, specifics of managing impedance and impedance matching and things like that. We won't be touching on those advanced design concepts within Altium. So this is sort of like general design concepts, and we won't be implementing any of those in Altium. We won't be talking about advanced library management or circuit simulation. We won't be doing anything other than two-layer boards or sort of really detailed output generation. We're not going to be experts. I'm certainly no Altium expert. I've only done 1 or 2 little projects in them, but we'll know the basics and we'll be able to put together a simple board sort of from start to finish. Okay, so what's the anatomy of a PCB? We'll start from the very simple, which is a single-sided board. So they consist of a insulated core. Typically, it's some sort of dielectric material, commonly referred to as FR4, which stands for flame retardant 4. So this is the core here, the big plane. There can be holes through that core to accommodate through-hole components. And then on one side of that insulating substrate, we've got some copper conductor which is deposited on there, and that's what makes the electrical connections. So basically little wires stuck onto that, the FR4. If we shape the copper into a specific shape, we can make a footprint, and we can use that footprint to mount surface mount components. So this is a really simple single-sided board just made up of a dielectric core and then copper traces deposited on one side of that. You can make really simple single-sided boards at home, given the right materials. You can etch your own. It's a sort of chemical process. So on that board, we can put 2 main types of components. We can do through-hole components, which is if you've been dealing with breadboard style circuits, a lot of your components have leads or legs, and they're basically through-hole components. And the other type, which is particularly synonymous with PCB design, is surface mount technology or devices, so SMT and SMD. And that means it's a component, they come in typically a standard size package, and they have a standard footprint, and the electrical connections are made directly from a copper pad to the component itself. And that's what a through-hole component looks like. And you should recognize a lot of those. And here's what a surface mount component looks like, which, they just look like PCBs. Sometimes boards will have combinations of those things. But modern PCBs are all about surface mount components. But sourcing through-hole components and soldering through-hole components is typically a lot easier. So SMT packages, as I said, they're standard sizes, and they're typically referred to by this code, which comes from the imperial dimensioned sizes. So if I was referred to an 0603 component, it would be basically a rectangular package like this that has these dimensions. And we typically use the imperial designator to refer to that component. So an 0805 component or 0603 component would fit onto that standard size footprint and package. The metric designator obviously follows the metric dimensions where it can. So if you didn't notice, the designator follows the dimensions. So 0201, sort of 02, and then 01 for the width, so length and width. 0603, there's the 06 in the length and the 03 in the width. Similar thing for the metric, but imperial's more typical. So that's the physical package, and then the footprint has, again, some standardized dimensions that go along with it. And remember, the footprint on the circuit board would be little squares or rectangles of copper that we then solder the component onto. The footprints have a lot, so there's a lot. So here's a picture of a bunch of different footprints. You're probably recognizing some of these shapes. They come with different standard sort of text designators for the type of package. So SOT, small outline transistor, TSOP, thin small outline package, all this sort of stuff, BGA, ball grid array, a lot of stuff you may have heard already is like DIP, like dual inline package. That's for through hole, but same sort of designators exist for the surface mount technology as well. So there's a bunch. This is only a very small subset of what all those named packages are. Right, so our boards are starting to get more complicated. We can do a double-sided board. Looks very similar to a single-sided board, except the copper traces are now on the top and the bottom. So why might we do that? Well, it allows us more flexibility in our routing. So remember, these aren't like wires where you can physically like take one wire over the top of another. You can't cross traces unless they're part of electrically meant to connect. So if you're trying to get traces everywhere, you need a bit of flexibility in the routing. So having two sides of the board to deal with can be quite handy and often necessary for more complicated circuits. And you notice here, you can have what's called a PTH, or a plated through hole, which is where that copper is actually deposited, not just on the top and the bottom, but through the outside, or depends what way you look at it, the inner diameter of the hole through the board. So just the difference between this hole here and this hole here is that this hole is a plated through hole. These are going to look very similar to something that is called a via as well. We'll learn a little bit more about those later, but a via basically can take an electrical signal from the top of the board through to the bottom of the board. Because remember, these would be electrically connected to the top and the bottom. So no difference to running wires, except those wires are just stuck onto that core. Once we've got our copper deposited, what we do, we put over a solder mask onto the board and over those traces. So it's a thin polymer coating. It's got a couple of purposes. It prevents solder bridges between tracks if they're running really close together, and generally just protects the raw copper. And it's historically that green PCB color, but nowadays getting it in any color you like is definitely achievable. So you've got your core, you've got your traces, chuck some solder mask on that. Next up comes a silkscreen. So silkscreen is the printed visible information. So the text stuff for humans to read, component identifiers, any assembly instructions, logos, all that sort of stuff. It's called a silkscreen because it's applied, or at least used to be applied, in a similar method to screen printing. So forcing an ink through a fine screen mesh. And there's obviously physical limitations to the sort of stuff you can print. So like how thin you can make a letter or a character. And it depends on the manufacturer, what their tolerances are. So you should be aware of it. Otherwise, if you try and print stuff too small, it's just not gonna work out. So there's a silkscreen. Another more complicated, again, board, where you can just start stacking up boards and basically stacking up those cores, that FR4, doing the routing on either side of those board with the copper traces, and potentially doing big lots of through holes or through separate, through all those layers of the board. So you can imagine what sort of routing possibilities and capabilities would have with multiple layers. So particularly on stuff with many pins, like those BGA ball grid array style, maybe like an FPGA or something, where you've got many pins, like dozens of pins or even hundreds of pins. You just got to use all your layers of your board to try and route those signals wherever you need them to go. Otherwise, yeah, you're just never going to get anywhere because you're physically not going to be able to route it. Commonly used as well is plane layers as well. So it's like a large deposit of copper all across the surface, sometimes called a pore. And we typically use those for ground, or like a DC voltage, like a VCC or something like that, 5 volts or whatever. That's useful for shielding, and also, means, ground and VCC are sort of used all over your circuit. So you can just sort of tap into that layer and get those, get that signal where it's needed quite easily. So as I said before, a via. So a via is a way to route a signal between different layers or opposite sides of a core. A plated through hole is a type of via. It's going to allow for more versatile routing. There's another thing called a blind via, which only surfaces on one side of a board. So for example, this first little via here on this one, or sorry, the second, would be a blind via because it's only has the sort of from the top. These are all the way through, and this one in here would be like a blind via because it's only in the middle routes between those two internal layers. There's a lot of manufacturing considerations to think about when you're designing your vias. So, you know, because there's a drilling process involved to get those holes, and which are then plated. So you've got to think about how they're going to be drilled and physically how those boards are being made. So careful if you're doing multi-layered boards and where you put your vias and how you design them. Bit of terminology. If we say a tented via, that's when the via or the hole through the circuit board is covered up by that solder mask. So you may not actually see the hole on the board. It doesn't look like a hole because it's got that solder mask going all over the top. That's called a tented via. Okay. Measurement units. Now, PCBs sit in this weird limbo between imperial and metric. So being from a metric country, we like to design stuff in millimeters, and we're all familiar with that. Unfortunately, being, you know, America being the powerhouse that it is, have taken control of some of the associated dimensioning here, and very commonly to use thousandths of an inch as a standard measurement. In mechanical engineering and machining and stuff, you typically refer to that as a thou, 2 thou or 3 thou, but in PCB design, it's referred to as a mil, so MIL, so from milli-inches, 1,000th of an inch. So 1 mil equals 0.0254 millimeters, and a lot of the standard pitches, pin pitches are in mils, so that headed pitch are 100 mil spacing. So you've got to be real careful when we say mil, because commonly in Australia, if we're referring to millimeters, we might be lazy and just say mil, you know, 10 mil. So we talk about millimeters or mil, MIL. We need to be sort of really sure about that. And we'll find in Altium, we'll be switching between mil and millimeters quite commonly. So just be aware of that. It's a bit annoying, but got a deal. All right, any questions about PCBs in general? Hopefully you've all seen and held a PCB, but knowing now how they're made, what the components are, it's going to make designing them a lot easier. It's not, you know, there's no real magic happening there. We're just putting copper and making electricity go where it needs to go. So, design process in Altium. What are we going to be seeing? So there's 3 main bits to actually designing. They're all sort of interlinked. Typically, we'll start by sort of cultivating our libraries that we need. So we know what the end goal of our circuit that we want to build is, what our project is, and we know that it involves like some resistors, some capacitors, you know, a couple of ICs or whatever. And the first step towards building that is making sure that Altium has access to those. So all the components are stored in component libraries, and this is maybe one of the hardest parts of cultivating an Altium project is making sure your component libraries are set and dealing with that. I still don't have the best way to work with libraries. We'll be doing like a really quick and rough and dirty sort of way to interact with the component libraries, but yeah, it's a whole thing. You can imagine if you're a big company, you've got your own supply chains and stuff. You want to make sure you know how many resistors you've got in the warehouse, and if I put through an order for 1,000 boards, is it going to be able to get made? So you can link those libraries up to like supply chains and whatnot, and inventory management and things like that. So once we've got our components sorted, typically we'll then go to the schematic design part of PCB. So obviously we need some sort of electrical layout. And we don't usually start with the PCB itself. We start with the electrical schematic. So drawing your circuit diagram. And once we've got our circuit schematic defined, then we'll take that over into the PCB design side of things, because the schematic design obviously defines what our electrical connections are between all the various nodes and components. And the PCB design relies heavily on that to make sure it can be routed properly. Technically, you can jump straight to the PCB design, but it's nice to have the schematic in there as well. It makes problem solving a lot easier. So it's sort of like 1, 2, 3, but oftentimes your design will change. You'll need to add in new components. So you'll be switching between these a fair bit as changes come up. Once you've got that sorted, you generate manufacturing outputs. So we need to obviously get these boards made, and that'll be sending off what's known as a Gerber file. So Gerber file defines how to make a PCB, and we can output those Gerber files from Altium, and then we send those Gerber files off to the manufacturer. And then the manufacturer will make the boards and then maybe assemble them for you. So if they've got the components and you've given them assembly documents, they may put the components on the board and then send them back to you. Sometimes they'll just send you back the board that they've made, and it's your job to put the components on yourself and source them. So it depends on what you do. There's, as I said, libraries can be a little bit complicated. At least they were super confusing to me when I first jumped into Altium. So in the design domain of a schematic, we deal with symbols and a symbol library. In the PCB design domain, we've got a footprint, and they're held in a footprint library. In the 3D domain, so the physical domain that defines the physical construction of the component, we deal with potentially step files or SolidWorks files, and they're used for like, detecting collisions between components, physical clearance heights and things like that. Additionally, Altium can do circuit simulation, so SPICE models, and this thing called signal integrity, which I haven't had really a chance to get into, which is, can help you make sure you've designed your PCB correctly if you're doing a specific thing like, RF design, or making sure traces aren't coming too close together for crosstalk and whatnot. So the signal integrity, I haven't done much with that and can't tell you too much about it, but it is there. And even though we've got all these different design domains with all these different library components to manage, we've got the schematic symbol, we've got the footprint, we've got maybe a 3D model. Altium sort of wraps that into this thing called a component. Now, a component may or may not have all these different attributes that go along with it. So a component can just be the circuit symbol. It could just be a footprint by itself, but typically it'll all be wrapped up in this one thing. So be aware of that. Hopefully I don't need to explain too much about what a schematic is. You should have all seen them before. The thing that's going on behind the scenes that we want to be aware of is this thing called a net list. And that's the thing that stores the connectivity of your circuit. So what is connected to what, and that helps with the routing immensely. So to do once we've got our net list defined and our schematic complete, we then come over into the PCB design domain, and we do things like importing the net list and the schematic design. So that tells us what sort of connections are required. We tell us the board stack up, so how many layers do we need to be, what shape and size does our board need to be. Then we'll start laying out our components, and then we'll start joining up those component pins with traces, and then we'll sort of refine all the aesthetics and things like that. So that's generally what we're going to be doing when we start on the actual PCB design. Once we generate outputs, we'll get things like the Gerber files, as I said, something called an NC drill file, because the holes on the PCB, it just starts off as a sheet of polycarbonate material, which then a drill has to come along. Some of them are really small drills, like fractions of a millimeter in diameter, but it's still just drilled manually, CNC, well, yeah, CNC, not manual. Maybe we want purchasing outputs. So what's the bill of materials for our project? How do we make it? All that sort of stuff can be defined in the outputs. And the manufacturing process itself can be quite involved. So the PCB Wade's got a good overview of what their manufacturing process is. It's always good to know. physically what's happening with these processes helps us be better engineers and designing in the design process if we understand what the people down the line have to deal with. And then we stuff our board when it comes back or populate it with components. And that can either be done by hand. You can do surface mount soldering by hand. I haven't actually done any yet, but I should be getting into that somewhat soon. And then more commonly for big scale manufacturing, we use pick and place machines. So CNC style component placing and soldering. If you're really keen, you can make your own open source pick and place machine, basically adapted from a CNC or 3D printer style project. All right, any questions? No, love it. All right, let's get Altium fired up and we're gonna jump into our first design, which is gonna be a simple little LED flasher with a 555 timer. Yeah, so an NC drill file. So Yufan's got a question here. What's an NC drill file for? So it's sort of used in conjunction with the Gerber file. Again, I'd recommend jumping onto a manufacturer's website to get sort of the hard truth on this. But from what I understand, the NC drill file defines exactly where and what size the holes in our PCB need to be. So if we're doing like mounting holes or anything from vias, or through holes, exactly how those holes are made and how they're laid out are defined in the NC drill file, which, yeah, I guess needs to be separate from the Gerber file. I'm not super sure of exactly the layout of that. All I know is that you sort of, at least for PCBWay, you need to get the Gerber files and an NC drill file. Okay, cool. So let me drag Altium over here. Make that a bit smaller. So you've all got the, if anyone missed it, if you weren't here at the time, let me quickly repaste that link to the slides. I think there was a couple of people joined after. Because mostly I'll be looking at the at Altium itself and have the slides on my other page. But yeah, so Altium. We're going to be building this simple little 555 LED flasher circuit. We'll be working through it all together. It's pretty simple, but yeah, it's our first design. Should be a bit of fun. So we're going to create a new project. So if you open up Altium for the first time, you should get something looking like this. There's a little welcome page and you should have chucked in your licenses and got all that stuff sorted. So we'll create a new project just by going new project. Yeah, and obviously we need to make sure we put it in the right spot. So the usual file choosing thing. Yeah, that's fine. And I'm going to call mine Flasher 3 because this is the third Flasher project that I've done. Just call it a Flasher or whatever you need to do. I don't think there's any parameters particularly that we need to do. No. So we'll just create a new project, pretty standard for this sort of stuff. And that's going to populate your projects window with a flasher.prj PCB, so project PCB. So an Altium project is made up of the upper level project file, and then there's bunches of different files that live within that project file, which we'll add to. So that's the simple one. And these sort of tabs is where your sort of individual files will be opened up. So you can close those off, close all the documents there and just be left with that. And obviously you want your projects panel and this sort of quick panel to be accessible. There's a bunch of stuff that'll happen over in there. Okay. What else is on here? That's all pretty self-explanatory. The other thing that you might want to access is the this little panels bar down the bottom, in the bottom right, you can click on that and bring up some other useful panel windows if they're not there already. So that's what the basic overview of the Altium workspace looks like. Okay, so let's have a look at what components we have access to by bringing up the components panel. So what libraries do we have? What resistors, capacitors, LEDs and stuff can we access? What do their footprints look like? And is there anything that we don't have access to? So you can go panels down here and then components. And that's going to bring up this this panels window. It may pop out for you potentially, depending on what it looks like. But yeah, in this drop down, you should have your different libraries. So INT is for integrated library. As I said, Altium libraries are pretty confusing. So I think I've downloaded a couple of additional libraries. I think these last 3, but hopefully you guys have, and maybe someone can confirm on a fresh install, you've got the miscellaneous devices and miscellaneous connectors and access to those. Yeah, cool. So yeah, let's just have a look at some miscellaneous devices and just have a little scroll through. Obviously, there's a bunch of stuff that should start looking familiar. Let's maybe open up or search for a resistor. Res, we can have a look. There's a bunch here. So res 1, that's what its circuit symbol look like. Here's its footprint. So you should be able to see from the footprint that this one is a axial through hole. Sort of looks like a through hole. Resistor 2, similar. Resistor 3. Okay, so here we go. Here's a surface mount resistor, is res 3 for me. And we've got a bit of an option to choose a footprint that would be associated with that. Seeing some of those familiar designators like an 0603. We've got a few different options here. So it's basically looking for what, what combination of schematic symbol and footprint suits our needs. Now, obviously these can be altered after the fact, but typically to minimize headaches, you just try and look for one that's got all the stuff that you need. You can obviously make your own circuit schematic symbol, make your own footprint, make your own 3D model, and you've got yourself a component. But yeah, we've got those. Maybe we can have a look at capacitors. Again, there's sort of a radial style cap, polarized caps, cap 2, various different other style of capacitors that we might use. The other thing for our circuit, if we remember what we're making, just keeping that in mind. Obviously, the other one that we need, we might need an LED. So we have a look for an LED. So circuit schematic looks good. Maybe this is obviously one the legs go through and then the legs are at right angles to the LED. You can probably find this is a common SMD style LED footprint. They've got the chamfered edges on one side to indicate polarity. But yeah, depends on the sort of package. There's a lot of information that goes along with these things to pull out exactly what you need. So there's the LED. The other thing that we're going to need is the 555, and you probably don't have one. We just look for 555 or something like that. Certainly don't have any in miscellaneous devices. It's not going to be under connectors. If you're interested, the connectors just have, all your different mounting style connectors, headers and whatnot that go along with those. So yeah, we need to source a couple of components. One of them is the 555. So any 555 is going to be on that is a problem for us. So it says need more components, try the manufacturer's part search. So we're going to do exactly that. We're going to have a look at the manufacturer's part search. what this is going to do, hopefully you've got an internet connection, and it's going to hook up to an online database and have a look for some NE555 timers. And we're going to get a big gigantic list, all these different suppliers, all these different package types, and yeah, basically whatever we need. So have a think about what we might need to use for that, what the schematic looks like, what's the footprint look like, what do we want to use for our design. This is all part of it. And as I said, I think the green indicates the lifetime of the part, whether it's actively in service. The red ones might mean that it's a little bit out of date. So manufacturer life cycle, this one's obsolete. So obviously if you don't really want to make those, but ultimately you got to choose what's right for your design. Okay. Check if I haven't missed anything. So there's effectively a bunch of different ways to manage your libraries. If you're just making a one-off project, potentially picking and choosing your components. If you've got a big stack of stuff sitting in your components drawer that you want to use, you want to make sure you've got something that matches that. I'm not going to get too in-depth with the library management. There's a lot of stuff. You can also create your own component symbol, footprint, and model and things like that. Okay, so let's start with our schematic design. We'll talk about how to use these models later. So back to your projects tab, right-clicking on the project .prj.pcb file and saying add new to project and add a new schematic to that project. So that's going to add on a new schematic document and make sure it's in the project hierarchy. So we'll do that. Might just make sure that's named appropriately. Flasher, and remember these all have different extensions. So just calling it Flasher is probably okay. And it just updates the name as expected. And in Altium, there's a difference between saving your document, which in this case is the schematic document, and saving the project that's associated with. So I've got the little star next to the project, which indicates that my project at that top level is unsaved. So yeah, you can save that as needed. Right, so we need to start laying out our circuit, and probably the core of it is that 555 component. So we need to start choosing that and basically choosing an appropriate one. So we do the search like we did before using the manufacturer part search, find one. Now have a think about, it obviously doesn't really matter for this case, but the main choice that you're going to want to make is, do I want a through hole 555 timer or a surface mount 555 timer? And obviously it's going to affect your design later on when you're making your PCB. So choose one. I don't really mind which one you choose. It'll be good to see some variation perhaps and see how you tackle the actual design for that. But yeah, let's try and have a look for a 555 timer. I don't like that one. Maybe I'll choose this through hole one. I think looks probably okay. And obviously, you want to check that the pin numbering is standardized if you're referring to a different schematic. So I'm going to choose this one, I think, unless maybe I want a surface mount. I'm going to go a surface mount this time, I think. Why not? Yeah, I think I did through hole last time. So I'm going to go surface mount, which is a NE555D from Texas Instruments. Standard timer, single 8-pin SOIC. So think small outline integrated circuit if we refer back to our naming conventions. So I right click on it and I'm going to go place. And just going to put that one in the middle. Okay, and escape will clear out your active selection to place. Cool, so then we just start building our circuit up around that, placing components. and then yeah, getting our circuit schematic made. So we'll use probably a CR2032 coin cell style battery. So I'll have a look at one of those next and see how that goes. Just search for bat, see what comes up. Nothing really useful there. I forget what the magic search term was for this one. I don't think anything came up over 2032. Oh yeah, there's a couple. 2032 seems to be the coin cell holder. So there's the batteries themselves or a holder to work with. So I'm going to go a battery holder. Something like that looks okay. Obviously, you can check out the 3D model, think about how that's going to affect the design. But yeah, something like that looks okay for my uses. So I'm going to place this one. So I think the place button is, can I just right click on that? Where is place? Have I lost it? If you need to rotate a component, if you double click on it and bring up the component properties, my window was not pinned. I'll just make that a bit bigger. Sorry, my Altium is running really slow today. If you need to rotate something, it's in the properties under the location dropdown, and just choose one of those, the one that works. So 270 for me to get my plus and minus sensibly aligned. So the properties is a reasonable thing to have up. So you can dock that into your panel there. Good. Okay. So what else do we need on our thing? We need some resistors, components. So I'm going to go surface mount resistor. I'm going to use a 0603 package. So that one looks okay for that. Place, I don't remember how many I need. I'm just going to chuck a bunch down. I think there was maybe 5 or 6. Go back to that schematic. We need 1, 2, 3, 4. 4 resistors. So I've got way too many there. Delete some of them. Four resistors. I need 1 capacitor. So let's have a look for a little capacitor. Just choose a footprint. There's an 0603 one. I'll keep with the theme and do an 0603 surface mount capacitor. And I think that was all the main bits of, no, I need LEDs, don't I? Again, I'm going to stay with the surface mount train. I'm going to use LED 2, which is again, a surface mount LED style package. And I need 2 of those. Yep, so how do we drag and move the schematic sheet around? Right click will do the pan. I think Control Scroll for me does zoom in. And yeah, you can obviously do like box select. I think, yeah, clicking my middle mouse wheel also does a zoom in and out as well, but control scroll I have a bit more control over. Yeah, some of these shortcuts and key commands are reasonably similar across these sort of programs, but sometimes they just make slight changes that just screw you up. Okie dokie, so let's lay this out a little bit. I'll go a little bit from memory and also referring back to the design where I need to. So you've got the design there as well to reference if you need it. Let me just check the polarity of those. So they're both, yeah, that way. So 270, 270. Yep, and then we've got so place your components first, and then we'll join them with wires, and I'll show you how to do that. So you got to make sure your nodes are all connected. So that was there. We had 2 over there and a cap down there. There's probably a shortcut for rotate somewhere, but I can't be bothered finding it. Let me know if you do. I should probably try Control R or something. Okay, so there's my rough circuit schematic. It's not going to be the prettiest or most optimized thing in the world, but that's my layout. I'm going to do component values next. So 68 ohms on the LED resistors. So obviously you want to open up your properties. And then where do we do the value? Should be somewhere. Do you just click on the, I haven't used Altium in a while, so sometimes there it is. So clicking on the 1K portion that comes up, you can change the value. So again, schematics and PCBs in particular are purely cosmetic, unless you need to do simulation type stuff or actually building it. So it's good to get in the practice of defining things in the correct way. But me putting a 68 is not really going to change what the PCB function is. Okay, and then we had a 220 and a 22. Up to 20K, 22, and then a 10 microfarad. Yep. Okay. Anyone run into any major issues with getting the correct components onto their schematic? May not have them routed yet, or maybe you do. Now's the time to speak up if there's any troubles. And we will be taking a break very soon once we got this wired up, and before we go into the PCB design. I usually take a break after an hour, give a chance to stretch your legs. So, all right, assuming everyone's okay, we're going to start basically wiring things up. So up in the top of your circuit schematic, you'll have like a quick toolbar. The wavy looking one is defaulted to wire, but you can click and hold on those toolbars to bring up other options. But yeah, we want the wire, and that's going to look like a little crosshair. And we just start wiring things up from the nodes as needed. So it looks like it's going to go red as we join up nodes. And scroll in. And just joining things to things that they need to be joined to. Should be pretty familiar with this style of stuff if you've done any LT splice. You go to there, you went to there, I think. I'll do the pins of the IC in a second. Yep, okay, so these LEDs get wired to the output, which is pin 3 of the 555. Let's see, plus 3 volts goes to pin 4 and pin 8. Don't know whether that's correct for this particular one. Certainly VCC is correct. Yeah, I think that's correct too, because it's an inverting, not reset, so that sounds fine. Then we've got ground to ground, obviously. And we've got 2 and 6 to the capacitor. And then 7 to that voltage divider. Where's 7? All the way over there. Lovely. And then I believe pin 5 is just floating from memory. I think if you look at the specs for a 555, you'll find some recommendations on what to do with pin 5. Sometimes it's leave it floating. I think sometimes it's tight to ground or VCC. I'm not sure what happens in this case. But what I do remember is if we don't want Altium to have a hissy fit, we need to define a rule suppression, which we'll talk about in a second. So escape to stop your wire placement as well if you need to. Okay, so that's the start of that. Now, rule suppression. What we might do, we might just try and see what happens first if I go project and then validate PCB project. Okay, so validation is Altium running a bunch of checks to figure out if everything looks nominal. So we've got a couple of issues here. Duplicate component designators. We've got undesignated components. So that is because every component needs a unique designator. So typically you'd be seeing like R1, R2, R3, R4, et cetera, when they default it, it just goes to R question mark because there's no concept. So we could do that manually. There is a way to automatically do that. The other thing that we can see here, pin 2 has no driving source, which is okay. And pin 5 has no driving source and pin 5 is unconnected. So what we'll do, we'll place a no connection rule check. So on this third last little quick tool, looks like a circle with an I in it default. So you want to click and hold down on that and then go generic no ERC. That's going to change our tool. And we're going to place that generic no ERC onto pin number 5. Okay. So ERC stands for electrical rules check. So we're going to say, okay, Altium, I know that pin 5 is not meant to be connected in this case. So placing that rule suppression on there is going to help us out. If I go project validate PCB again, we're going to lose a bunch of those error messages. Okay, so let's see if I can recall how to auto designate all those components. Does it annotate schematics? I think it is. Yeah, I think it is. I don't remember how to use it though. Designator. Start index 1. Is it selecting all of these? Maybe. Let's just turn all of them on and see what happens. Update changes list. No changes were made. Told you I'm not a an Altium back annotate maybe. Nope. I know there's a way to do this. First one to figure it out wins. Reset duplicates. Nope. Propose. Change. Designator. Lock. I don't want them locked. Until just answering your question, what I did for pin 5 was to go to the third last tool and you click and hold down on that. And that gives these options. You want to select the second one, which is the generic no ERC, which is electrical rules check. So no electrical rules check. So just select that tool and place it on pin 5. Yeah. Oh, the other thing that I'm missing that you'll want to add in is a ground as well. So just pop that onto the negative terminal of the battery. Obviously reasonably important. Okay, back to trying to figure out how to do this damn component labeling. Reset duplicate designators. No designated changes. Annotations, force annotate. All right, let's try that. Force annotate all schematics. 9 designators requiring update. That looks promising. Proceed with changes. Yes, okay, so that worked. So that's replaced the question marks with a reasonably, yeah, hooray. That's replaced the designator with a reasonably chosen number. So then if we go design, and, project and validate PCB chain board, we see pretty much everything coming out okay. Net 1 C2 has no driving source. Net 1 C2. Pin 1 to 2. Yeah, I think that's okay unless I haven't connected it up properly, but it looks like I have. So yeah, we're going to assume that message doesn't matter, but we got a green somewhere. Feels like I had this problem last time, but maybe not. Maybe I'll just try deleting that wire and trying again. Yep. Anyway, if it's looking okay, what we'll do, we'll take a 10-minute break or so and come back and start on designing the PCB very, very soon. Maybe 1/4 we'll get started again. When Luke goes to validate, nothing comes up. Well, that's promising for John. What have I done wrong? I thought I was meant to be the one teaching you guys. All right, well, I'll try and figure that out over the break.
Sorry, John, what I was trying to say is if nothing comes up, like no window comes up, does that mean you're all sweet?
You can check on the messages panel. So if it's not part of your panels list,
there we go.
Very right-hand panels and ticking off the messages one.
Yeah, I've got the same thing as you then.
You've got the same thing?
I've got a warning, yeah.
Yeah, all right. So yeah, I'm gonna assume that that's not gonna cause too many issues down the track. All right, yeah, I'm gonna go off video and on mute for a bit. So I'll see you back at 1/4. All right. Welcome back. We should all pretty much have a circuit schematic that looks something like that in the slides, or like that for the one that I'm working on now. Obviously, some of your symbols may look a bit different, but the circuit should define the same thing. Okay, so we're on to creating the PCB side of things now. We're going to add a new PCB document. So to do that, we go to the projects panel, right click on our project and add new to project, and then PCB. I'll do that. So project here, add new to project, PCB. Ifan, I don't think it's going to matter. So the only thing, you know, obviously creating a correct electrical circuit that does what you want, you need to make sure the chip that you're using is the right one. For our purposes, we need to basically make sure we've chosen an appropriate package. So whether it's surface mount or through hole, again, it doesn't really matter. But yeah, so in short, no, it doesn't matter. The PCB design window sort of looks like this, and we'll just have a quick summary of the three main views to refresh my memory as well. So there's going to be three main views, and we can get to them by pressing 1, 2, 3 along the row of numbers on our keyboard, so not the number pad. Number 1 is the board planning view. Number 2 is the 2D layout mode, which most of our work is done, so the laying out of the components. And number 3 is the 3D view. So you can click on 1, 2, and 3 to get between those. 1 turns the board greenish, 2 is black, and 3 will give the 3D board. And you can use the number pad keypads to change the views in the 3D view. So that's handy to navigate around. Pressing Q will switch between mil, MIL, and millimeter units. G can quickly change a grid size, which can be useful. And if you've ever worked with something like Photoshop or GIMP, you should be familiar with the idea of layers and how you navigate between layers and whether you're doing your creating on a particular layer. So the main ones are the top layer and the bottom layer, which is red and blue typically, which are the top and bottom conductors. So the copper traces on the top and bottom of our board. That's assuming a 2-layer board. Top and bottom overlays is the top and bottom silk screens. Top and bottom solder is the top and bottom solder mask. Top and bottom paste is the top and bottom solder paste. You'll be using the properties panel a lot, and you can use Control F to sort of flip the board. Works in 3D, also in 2D. So if you want to do a writing on the bottom, typically you'll flip the board and then select the bottom layer and whatever you need to do. Okay, so let's set up a simple 2-layer board. So go into board planning mode, which is hitting the number 1, and then design and layer stack manager. So 1, and then design and layer stack manager. And that is taking its sweet time. Come on, Altium. Properties, no. That doesn't look quite right. Ah, there it is. It's this one here. Sorry. Yep. So that brings up a new document in your documents tabs, which looks like this. And this basically defines what the how your cores are laid out, where your copper layers are, how thick they are, all the parameters of that. So you can create new layers as needed. But this is what's called a board stack up, and that's where it's defined. We're going to stick with the default one, which is a 2-layer board, so a layer of dielectric, 0.32 mil, which is pretty standard. FR4, 2 signal layers, one on top, one on bottom. So that's our copper layers. You can select the weight, which is basically the thickness of the copper layer that goes on it. So obviously the higher weight, the thicker it is and the more current and power those traces can handle, and the lower resistance they have. So that can come into design consideration when you're making a quote unquote proper circuit. So we're going to stick with the default here. So you can also select in the tabs down the bottom the different via types. So basically what we need for our vias is just the default, which is a through 1, 2. So whenever we place a via, it's going to be with this configuration, but you can define multiple types of vias and choose between them. So all the defaults are good for us. So we can just close that document, close the stack up document. Okay. Next, we'll go back into 2D layout mode and we'll just save our project and save everything in the project. So you might want to save your PCB document specifically. I'm going to call this flasher as well. So save that, save my schematic, save the project, all that fun stuff. So going into the 2D mode, so clicking number 2 on your row of numbers on your keyboard, you go up to design and import, what is it? Yeah, import changes from your PCB project. And that's going to bring up this window here. Okay, so basically it's going to bring in all the definitions of the connections and nets and from the net list that we had, and basically bring those over into the PCB document. So we've done all that work. We don't want to start from scratch, but first we can validate the changes first. It's always good to check what's going on, check that everything looks good, and once everything looks okay, we can then execute those changes.
Sorry, Jonathan, how did you get to this window that's just popped up?
Yep, so on the 2D mode, so that's clicking the number 2, the second view, number 2 on your keyboard, and then going design, and then import changes from whatever project is. So import changes from Flasher, project PCB.
Yeah, got it, cheers.
Yeah, so you can imagine with a gigantic PCB, if you've made a few changes to your schematic and you only want to import those, you don't want to import everything, or you don't want to ruin your document. So once we've executed those, we can click close. And off to the right, so again, control scroll is working for me to zoom, and I'm guessing, yeah, right click works for panning as well. Off to the right, it's imported all the footprints and overlays associated with the components that we dropped onto the schematic. Anyone run into problems there? Got an error, cannot locate document PCB1, PCB doc. Okay, so Ifan, do you, in your project hierarchy, does yours look similar to mine where you've got a PCB project at the top level, and then under source documents, you've got the Flasher schematic document and the Flasher PCB document? Yeah, okay. And is your PCB document called PCB doc, PCB1.PCB doc? Where it's named on yours, or just checking that. If it can't locate the document, it probably means that there's some sort of sourcing issue. I don't know exactly what that would be. Have you saved? I take it you've saved it. Design, import. Yeah, not sure what could be the issue there. Mantila, this stuff came after I validated and then clicked execute changes from that import. That should bring everything across. Yeah, okay. Cannot locate document. Just check, it's the PCB. Oh, you fixed it. Okay, forgot to save it. Yep. Cool. Yeah, so Altium, it's an engineering software, so it's got lots of stuff they can do. Sometimes it doesn't do everything very well or give you particularly useful stuff. Okay. Any other issues? Everyone up to a similar point? From here, basically, we want to start conceptualizing what the layout's going to be now that we can see what the footprints are. So I'm going to make a 2-layered board. I want to have the 555 timer sort of front and center. I want to have my battery pack on the back, if I can. And so the LEDs on the front, battery pack on the back, 555 timer on the front as well. Everything else will just sort of go wherever that needs to go to figure that out. And what I'm going to do at the end, my aim is to make like a little circular circuit board at the end rather than a square one. So that's going to be the design that I'm trying to keep in mind. So from here, basically, you can just start dragging things around and organizing. Now, for me, I know I want this battery holder to go on the back. So I need to bring up the properties first and foremost. And at the moment, the layer that footprint's associated with is on the top layer. I need to make that on the bottom layer. Okay, so I flick that to bottom layer, and then that's going to be associated with the bottom. I'm going to take my U1 next, which is my my surface mount, and note that this is a surface mount any 555 timer. So surface mount, you can get away with things that happen on one side of the board completely separately to what happens on the other side of the board. If this was a through hole 555 timer, you got to think about what's on the other side of that board. So there could be a collision. If this was a through hole 555, if that's what you've chosen, you're not going to be able to lay it out on top of that battery holder, because the pins are physically going to go through to the other side, and there's going to be a collision there. So if you've got a through hole 555, you might need to think about having that off to the side and routing those a bit differently. But because mine's surface mount, I can have mine on the front because it's on the front layer. Now, keep in mind, something to visually help you out is the 3D view. So clicking on the number 3 will bring up the 3D view of that board. And using Control F will flip the board. You can see what's going on. Again, you can use the number pad numbers to change some views around on the 3D view as well. So you can start to get a bit of a idea of what that circuit board's going to look like physically. So yeah, you want to keep in mind what sort of connectivity is going to go. What I'm going to do, I'm going to flip back to my board layout 1, and I'm just going to change the board shape a little bit because I know it's just getting a bit clunky having that whole board around. I'm just going to edit my board shape. See that there's a few different options there. Edit, redefine. I know I want mine to be roughly, let's change, maybe grab these ones. I know I want a roughly circular, so I'm going to start with a small rectangular. That's roughly the dimensions of the board that I'm going to end up with, just so I know what I'm designing to. Now, obviously, if you're trying to fit this PCB into an enclosure, you might have some physical mechanical requirements to meet, or it could be a weird funky shape. So, you know, keep all that in mind. So that's going to be my rough board shape. And now if I go to my 3D view, it sort of reflects that new board shape. So we just keep arranging components. I'm going to do my LEDs next because I know I want them to be on the front. And thinking about the physical layout of this, maybe I'm going to have them off to the side, and maybe I want to start thinking about symmetry. I'm going to zoom in a bit. I'm going to get a grid set up. So pressing G gives me access to quick grid, and maybe I want to start with like a, let's see, where's 1 millimeter grid. There it is. So you can sort of start to get a sense of scale. The grid's a little bit faint. You may not be able to see it, but hopefully you can see yours. maybe even I'll go a 2.5 millimeter grid. Let's just see if we can change our grid properties. Toggle visibility, visible grid size. No, that doesn't do it. Somewhere is the oops. I think under preferences. Now, obviously, you can set up your own preferences. Let's just have a search for grid. PCB editor. Oh, scripting system CAM editor. Somewhere you can change the grid properties to make them a bit easier to see. I'm not going to spend too much time trying to define them, but obviously you've got control over that if you need it. So I'm going to start aiming for symmetrical. You can also, it's under view and then, oh, I put it somewhere. Did that. Somewhere you can define the origin. Edit and then origin. You can set where like 0, 0 is. So I'm going to set mine at the center of my 555 timer. And that way that's where 0, 0 is. And I can start to get a feel for symmetry and things like that. There's also like alignment things that you can do. There's, you know, you don't have to place things really manually. We're just going to do it manually for now. So maybe I'll go out a little bit and have some fun with this design. Don't get too caught up in exactly what it needs to be. Change your grid size around. It's going to be a bit better. Yeah, how do you change the board size? Yep, so you've got to go back to board planning mode. So clicking number 1 and then under design and doing edit board shape or redefine board shape. I think it's edit board shape. You can do various things. Other questions? Yep. So G does the grids. And yeah, we're just going to keep aligning some of these components, keeping in mind the routing. Now you can see the lines which are indicating where the routing is going to have to be. So what nodes need to connect to what other nodes. So physically, we're going to have to make sure they're aligned in a good location. So I'm just going to bring these all over a bit closer. And I can delete that one now. Yeah, so I'll have those on the front. Let's have some fun. Let's put the capacitor on the bottom layer. Let's put, that's that, there's R4, and where's the other one joined to that? R2. So let's keep these ones on the top layer and put maybe R3 on the bottom. And R1 on the bottom too. Okay, so you can see that they've mirrored down to the bottom, indicating they're on the bottom. So I can Control F to flip my board, and that'll bring the ones on the bottom layer into the correct view and the ones on the top being mirrored. And we'll just align those. Remember, now I'm on the bottom layer, I need to make sure I stay clear of the battery holder. So potentially having these ones on the top could be a better design choice. But it's all just a bit of fun for this particular design. Might rotate that. So again, looking at the properties for that, and rotation, I'll set to 0 in my PCB. Oh no, I'll set it to 90 in my PCB. Maybe 270, just looks like the connections are going to go in that direction a bit better. Okay, so I've got a rough idea of where the layout of our board's going to be. It's not going to win any prizes, but it should get the job done. Now we need to think about routing. And if you can also hide a view. So under view configuration, I believe, you can select what's visible. So you can turn off, for example, what's on the bottom layer or the top layer or the silk screen. So remember, the yellows are the silk screen. That's the physical printed text that's going to come up. And we'll just take a look at the 3D view, sort of get a feel for how things are looking. Yeah, shouldn't be too bad. There's a bit of nice asymmetry happening there that I wasn't planning for. So maybe we'll move that one in there. Same with the resistor. Okay. Everyone got a layout that looks somewhat reasonable? Awesome, Sean, good job. Speak up now if you need me to slow down. Otherwise, we'll keep on trucking. Okay, so once we've got them oriented, positioned, you want to be reasonably sure on where that's going to be, because once you start routing, if you move it, you also need to move your routing around. So the more fixed and certain you can be at this stage, the better. So saving is a good option as well. Don't forget to save. Right. So we're going to do interactive routing. So we're going to define where all our traces are going between components. You can use auto route, where Altium will try and figure out the best way to put your traces to make the connections that are needed, but we're going to manually route it because it's good practice. So you can use Control W. Alternatively, you can click on the, I think it's this one here, interactively route connections. Yeah. So again, you can click and hold down and see what the different options are. We're just going to use the interactively route connections. And that's going to give us that similar sort of crosshairs to deal with. And basically it's similar to making a wire in the schematic view. Click on a pad or a connection and click on the sort of waypoints that you need to go by, and then click on the end result pad. Now, if you need to pass a signal through the board, we need to use a via, and we'll get that sorted as well. Obviously, the track width is quite important for having a good circuit do what you want. So in terms of resistance and things like that, so you may need to adjust the track width, which we can talk about too. So I'm currently looking at the top of my board. I might join up what I know needs to be joined up. Again, it's definitely not going to win any prizes. In fact, this layout, yeah, let's start here. So following from this pad here, you click and you can see the trace start coming out. Just going to come out to there, down to there, and then over to there, something like that. Next up, I'll do here, can just go straight from there. Maybe over to there, looks a bit nicer than going to there. And then what else do I need? So this has got to go to ground, which has got a couple of places. That's got to go all the way around. So to make this a bit easier, I'm going to stop doing that. I'm going to delete those traces that I placed. And just in terms of making my routing life a bit easier, I'm going to stagger these, put my resistor, say, up the top a little bit more. move this D2 designator onto the bottom. If I can, where's my view configuration? Turn off the bottom layer, turn off my bottom silk screen. Where is it? Designated D2. Should be able to select that designator. Oh, all right, I'm playing with me. But yeah, we'll have that there. That's going to make life a bit easier, and I'll have that staggered towards the top a bit more. Ooh, go back. Oh, go away. Oh, no. So yeah, once you can obviously optimize your selection stuff. And like select all of the traces at once. But yeah, once you place them down, it's a bit of a pain to get rid of. So yeah, we might have something a bit more like that. Should make my routing a little bit easier. Yeah, okay, so where's my wires? Start routing again. So there to there. Ground is going to have to go to there, so I can choose one from there. I can also get a ground from this through hole from my battery pack, so it can also ground that by going to that node. Makes things okay. Then this guy on this side, that goes to there. So that needs to come around to that side, so I can now bring that maybe around the outside. And go to there and that to there. So the you'll notice that the net names, so net D1_2, net D1_2, they start appearing on the traces, which is handy, so you can see what's connected to what. Okay, so net B1 has to go to there, to there, to there. So again, this is certainly not going to be winning any prizes, but we're just trying to get things done. And that needs to go through. You can route traces sometimes under the body of a component. So you need to be aware about physical clearances and things like that, but it's perfectly valid to pass a trace, you know, if it's allowed for that and works for that particular component back through the body of a component like that. Okay, now I need to start getting things happening on the bottom of my board. So one way to help with that is place a via. So this 1, 2, 3, 4, 5, 6 from the right tool is the via tool. And if you click and hold, it's going to place the either a via or a pad. We're going to do a via. So thinking about where I need to go, I need to get from one side of the board to the other for this net C1 over here for that pin. I'm going to place a via right here. And that's going to allow me to pass a signal from the top of the board through the bottom. Okay, so by clicking on the via and having a look at the properties, you can see you've got some via templates. There's just one template here, but you can change the diameter and things like that. One of the things that we need to do to help with our routing is define what net this via should be associated with. So I know I want to use it for this net C1_2. So you can use the eyedropper tool, is handy, and that'll apply the net to that. And then we can start associating the routing with that particular via. So back to my interactive routing tool, I can then connect a trace up to that via on the top layer. And then I can start thinking about, okay, well, now I want to start routing things on the bottom layer. So let's flip the board. And let's choose the bottom layer. Now I've got mine hidden at the moment. So you go back over to my view configuration, click on that, maybe bring that up again. And now I choose my bottom layer as the active layer from the rows at the bottom. And I can just start using my interactive routing tool on the bottom. So here's my net that I just, the via that I just brought through. So that's, I have access to that on the bottom. And click on that and route that to where that needs to go. And what else? I need another ground, so I can use the ground. Remember, ground is on this pin on the bottom layer as well. And just connect it to that because that goes through the board. That pin for the battery holder. Got a few others to do. I need to bring a couple of these down here. And the battery is not connected up yet. That BT1. Yep. Okay. Let's start here. Let's get a bit of rotation on this guy here. It's going to make that a bit nicer. 180. Yeah, something like that. Start routing that. Battery 1 from there to there. And I need to get up to the top layer for that guy there. So we'll use another via. Now you can see I'm getting some collision issues here, but if I change my grid snapping to be a bit smaller, I should be able to place that with a little bit more accuracy. And again, you need to be aware of what's happening with the battery. Again, apart from the through holes, the battery can sit fine over that. It's going to interfere with my the Silkscreen, or if there's an outline for the battery holder there, but that shouldn't be a problem. So add that there. Associate it with a net, and then route that one up. Route that on the top layer as well to that component. Yep, and I need to get that guy over to there. So again, I'll be using the via. If you're using a through hole, basically all the different legs of that through hole component are basically vias because they'll connect from the top to the bottom. So there's some advantages and disadvantages that we're seeing here. So that one needs to go to there. Let me place him like that. You might need to choose a smaller via size if that is helpful for you. Oh, I forgot to associate what net that was going to be connected to. So just drop that net name with that. That's going to help me route there to there. And then on the top layer, there to there. Ooh. Okay, now what was I missing? Getting a bit ugly there. I'm going to need to do bottom layer there to over here. And that's got to come back on the top layer, which I think I can do if I put a via there. And then drop that net on it there. So yeah, you'd probably want to spend a little bit more time choosing your layout to make your routing easier. So it's that balance between what you want it to look like aesthetically. Look, I could come around this side of my component to get to that guy like such. Okay, and what was missing? One more net. Really? Looks like I can get that by a very ugly trace on the bottom layer by going net C12 from there all the way sort of around to there. Nice and ugly. How did I define the via? I just used the default via. So that's the 6 tool from the left, 1, 2, 3, 4, 5, 6. Clicking and holding, you can see the vias and just selecting the via.
How do you know? Yeah, how do you know which net? Like,
yeah. So once you place it, you go to the properties for that via, and under the definition, there's the net. So at the moment, it's got no net. So you can select the drop down and select the one from the list, but easiest is to use the eyedropper tool and just click on the net that you want that to be associated with. So click on a
so
pad
it already knows which things you need a via point for, and then you select from there.
It doesn't know which ones you need them for. It will give you
it just gives you all the possible
ones. You need to know what you want to use it for.
Okay. Sick. Cheers.
No worries. And I think that's pretty much it. Potentially there's 2 terminals on this. I don't know whether they need to be joined, but we can just join those up. And we've got a very ugly looking circuit board. We can probably go project validate and see what Altium thinks I've done wrong. Still saying that net, no driving source, but I think we ended up okay. It looks like I've correctly routed all my stuff and haven't left any unrouted things. So that would usually come up if there was an issue there. So yeah, how'd everyone go getting their stuff routed? Anyone want to share what they came up with? Mine is, yeah, super ugly. I don't really like it, but we didn't spend much time defining and optimizing. No one wants to share theirs?
I would share, but it's pretty shit.
Share it, share it.
Debatable, man.
I'll share it, but it's only like 1/5 done.
Let's have a look. I'll be keen.
No, you've disabled participant screen sharing.
Oh, okay.
Otherwise, I would.
No. I can fix that. There we go. All right.
Get out of this.
There's my creation.
Yeah, nice one, Luke. Yeah.
I love the pause. Yeah. Nice.
Oh, it takes a second to digest. Cool.
Yeah, look at
So,
that.
yeah, it went surface mount on the 555.
Yeah, I went surface mount on most things, I reckon, other than the battery.
Yeah, so the battery. Good. Anyone else? Anyone else keen?
How do I stop sharing? Oh, there we go.
I can share mine.
Sweet.
You good? That's my circuit.
Oh, cool. That looks awesome. Nice. So you've gone the through hole?
Yeah, I think so.
Yeah.
And the battery's on the back, this giant thing.
Yeah. Yeah. So the only thing you'd need to be aware of is the clearance with the through hole. on the legs coming through, because if you think about how the chipped legs look when they come through, they do protrude on the other side by, you know, maybe a few millimeters or something like that. And if you're physically putting something on the back, you need to make sure you've got clearance around that. So depending on what the choice of the battery holder is, there could be some mechanical collision issues there. Nice.
Right.
Looks good otherwise. So yeah, basically routing as we need to. Did anyone try the auto route function?
Where is the auto route function? And is it reliable? Like,
Well, honestly, I've never used it before. Let's
is it just so much fun doing the routing yourself?
Yeah, well, it's good practice, I reckon. And obviously there's a bunch of stuff that you need to be aware of when you're routing, and all these automatic tools, you know, you need to know how they work effectively, to do it yourself and to use the tool effectively. So let me see if I can remember how to, select by, shall I select all on layer? Yeah, let's try something sneaky. I'm just going to delete all my routing, undo all my hard work that I just spent 20 minutes doing. And then, yeah, try the auto route. Looks like Matt's tried it, and getting the comment that wow, looks so much cleaner. So that's handy. Select all on layer, delete. Okay, here we go. So route, where's auto route? Auto route all. See what happens. Default 2-layer board. Yeah, I don't know. Probably a bunch of parameters you can change. Route all. There we go. There's whatever Altium has come up. It's obviously made use of the vias that I dropped in, I think, or maybe it moved them. Some of them look like they're in the same spot. So that's what auto route's doing. Thanks, Tien. No worries. Thanks for joining. So yeah, you can auto route, and it'll obviously select things to auto route if needed. So, all right, now we're almost done. One last thing that I want to do. Design rules check was the one that we want to do. Tools, design rule check. And there's basically a bunch of rules that you can define, being like track clearances, mechanical clearances, minimum track widths, and all that stuff. So run the design rules check from that. So we've got a few warnings here. Solder mask to silkscreen constraints. So that's basically saying that you know, our silkscreen things are not in optimal places. So being over the traces is likely triggering that. But if we went in and changed that rule, that would obviously, you know, make sure. So on big circuit boards, the design rule check can be absolutely invaluable. Okay, one last cosmetic thing that we're going to do. You can move all your placement, orientation, routing, and whatnot. We're going to add this route toolpath, which is going to define the shape of our board. So we follow these instructions here because I don't remember how to do it. So view configuration panel, panels, view configuration, add a route toolpath. So right click in the layers list and add mechanical layer. So under mechanical layers, right click, add mechanical layer, select route toolpath. Yeah, layer type, route toolpath. Okay. Okay, and then on the route toolpath, we'll select that down here. We're going to draw a full circle starting at the origin, being reasonably large. and then defining the properties of that circle. If I can get that to come up. And then we're going to change the width up to something like 2 millimeters, bigger 5 millimeters, bigger 10 millimeters. Yep, I can decrease my radius a little bit by a few mil. Let's see what 25 looks like. It's a bit too small. 26. Something like that. And then finalizing the shape of the board, just to minimize that. So back to the board view, design, edit board shape, and just making that circularly minimal. So the route tool does its job. Something like that. So there's our board, which is defined with a router tool path. And then I go back to my 3D view and I've got a nice round circuit board. So you can sort of imagine what your flasher would start to look like in real life. You can define that shape however you need to. So yeah, similar. I've changed the solder mask color. You can add in text and whatnot on your solder mask layers. Sorry, your silkscreen layers to add in text descriptions and whatnot. I'm not going to go into generating the outputs, but there's a link in there which will take you to PCB Way and run you through setting up the Gerber file outputs for Altium. So obviously PCB Way, when you send them files, they need to be set up in a certain way with certain parameters. So if you follow their list and guides to generating those outputs, that's going to make the correct file format for them. But yeah, there's basically it's slightly different between each manufacturer. So yeah, you could set that up and try and get a quote for your design and see how much it'll cost. So yeah, if you're up for a challenge, you can try and add a switch to your PCB to turn it on and off, but without redesigning the whole thing over. So that would involve going back to your thing. Is JLC a sponsor? I'm not sure. I'm not super up on what our current sponsors are, and I think Tien just left, so I'm not too sure. I think we have had some PCB associated, PCB Way associated sponsors in the past. I don't know if they're actively a sponsor. So yeah, you can optimize based on cost and whatever. Yeah, JLC. I think the last lot that I got made up was from PCB Way. We submit their quote and they just give you. I got this box from them, and the PCB that I designed for that was for a little. It's eating it. My background is eating it. Hold on, let me turn that off for a second. See my messy room. So yeah, the PCB that I designed for that was a little proto board. So basically like a solderable breadboard, which has got some club branding on it, and that's going to have, once I get around to it, like a what's it called, micro USB on it, a bit of voltage regulation, and a little mini polyfuse to basically use as a prototyping board. And we'll be giving those out to members if we can get the cost reasonable enough. So you can just have a little semi-permanent prototyping style board that you can just plug a micro USB into and have 5 volts ready to go. So that should be a bit of fun. I think that I got a prototype run of 20 made up, manufactured and shipped from China. I think it took a week and a half or so and cost 60 or 70 bucks Australian. for a run of 20. Now, obviously that gets cheaper the more you make, and you can optimize costs in certain ways. Can non-students get that next year? Yeah, I'll keep you in the loop, Annie, and I'm flinging a couple your way. So we're planning on getting a run of, I don't know, a few hundred done up, and probably use it as a bit of a surface mount soldering workshop as well, because there'll be some surface mount components for that, and then as well as, yeah, so you can either solder up yourself, or we'll try and get some soldered up. I think what's it called, the Telstra Creator Space has some good tools for doing surface mount soldering, as well as a pick and place machine apparently, and a reflow oven for all those massive runs of circuit boards that they plan on getting made. I don't know. So yeah, we'll try and utilize that in some way, maybe. But yeah, they're a bit of good. If you ever tried to take a design from a breadboard up to something more reasonable, you're either dealing with proto boards, which can get quite messy, and you still need to source your own power circuitry and stuff like that. So hopefully this will be useful for those tinkerers out there. Yeah, that's all I've got for you guys. So any last questions? Otherwise, yeah, happy PCBing. Excited to see any projects that you come up. Yeah, hit me up, Jing, with your panelizing question. I'll answer where I can. I know vaguely know about implementing that. The clearance, Jing, on the panelizing, check with the manufacturer. So they should have all those specs around. So if you're talking about, yeah, on, between the V cuts on the boards and where your circuit stuff is and whatnot, always good to check with the manufacturer. In terms of ballpark, I think it's on the order of millimeters. I don't think you need too much, but yeah, always check with the manufacturer. And Tilly, great question. How do you simulate circuits on Altium? I don't know. I know that you can do it. And you can do a splice simulation internally. You can export your netlist and take that into Spice manually. You can also do the signal integrity simulation and checks within Altium, which I've never done before. So yeah, let me know if you come across that. But in terms of specifics, yeah, I'm not sure, Mantilla. You'll have to jump on the Google and the stuff to figure that one out. Yeah, and there's a bunch that we haven't covered really, but yeah, going from what we just did to manufacturing. Yeah, from there it's just checking in with the output generation and submitting it off to your manufacturer of choice. Yeah, that's it. There's for big runs, getting it optimized is a huge thing. So yeah, panelization, getting that sorted out, it's a bit of an art form in itself. But yeah, check with the manufacturers, see what they do. They should all have pretty good sort of. I know at least PCBWay's got good customer service, so they've got people working around the clock to get your orders going through in the best way possible. So you could probably ask them. Microvires, really only by name. I think they're drilled in a different process, and yeah, you can get them set up to obviously make your vires smaller and done differently, particularly for the blind vires and things like that. I think, yeah, there is some specifics around them, but yeah, worth jumping on the docs and seeing what the deal is in Altium about those and their use. But yeah, certainly comes into play for making nice compact circuit boards, multi-layered boards with those blind vires. All right. Thanks, everyone. I'll be chucking this recording up on the YouTube at some point, so keep an eye out for that. And yeah, if there's any issues, reach out and keen to see your designs. Thanks.